Hi, class. I want to talk about the week 4 project. And again, this may or may not be the version that you're working on, but this is going to be very, very similar to uh, the one that you would have. And I'm using the online version of Statdisk. And of course, we need to open up a data file first. So it says here, open the file body temperatures, and that's the Elementary Statistics 13 edition. So we go to data sets over here. Elementary Statistics 13th edition, and then the body temperatures. Okay. So we have the data here, kind of popped into the data editor. And it says, how many observations are in this file? And again, now we got some missing data. So it's, do we really need to count every one of the ones that are missing or whatever? But it is, it's okay to kind of approximate on that. It says how many observations are there. So basically, every one of these letters or numbers are considered an observation. And it looks like for gender, we have male and female, and there's 107, and this one has for smoking, yes or no. There's another 107 there. And day 1, it looks like they took temperatures for a lot of people, but some were missing. So, but roughly, again, you could put in there and so on, how many. And it looks like, again, day 1 at 12 a.m. They took some measurements and roughly maybe 100 or so. So again, you've got 1, 2, 3, 4, 5, 6 different columns of data, and 107 in several of these, and then some less. So we would say that there's 500 or some whatever. But they say here, number 2, what do you expect to find in this data relative to the body temperatures? And again, that's just something you kind of guess at in a sense. But so for part 2, though, it says generate descriptive statistics for all 3 groups of people. So you have the day 1 group, the day 1 at 8, day 1 at 12, and the day 2, 8 and 12. Right, so day 1 at 8, we can get descriptive statistics by going into data, and then it says explore data, descriptive statistics here, and explore data from columns. Now you got to select, right? Day 1 at 8, evaluate. And then you are asked to find the sample mean, sample standard deviation, and sample size. So the day 1 at 8 a.m., it says here the sample size n is 38. The mean, 98.13, we could round that up a little bit. Sample standard deviation, that's the S here, 0.75. We could say 0.755. Okay. And then for the day 2, you can go up here and go to day 2 at 8 a.m. Evaluate. And then you get sample size 70 for that. The mean is given. Here's your standard deviation, and you get for day 12. So you get that, and then you answer some questions. Now, part 3 says generate 95% interval. Day 1, 8 a.m., right? Day 1, 8 a.m. So let's go to analysis. Confidence intervals. and then it says that we want a confidence interval for the mean. So one sample mean, right? We want the confidence interval and 95%, so here's 0.95. Sample size. And then for that, again, we got to plug in the sample size for the day 1, 8 a.m., right? Whatever sample size we had there, for example, like 38, you got to put that in there. And the sample mean, and again, I'm just kind of making these up. We did go and look at that, and 9 point. I'm just putting some numbers in here. Sample standard deviation, and I'm making this up. 2.3. Population standard deviation not known. And evaluate. And so yeah, your confidence interval is basically just a range of numbers. So here, this is a range from 8.68 up to 10.19. So that is your interval of numbers. It's a confidence interval. And your margin of error is really from the middle out to the right or from the middle always down to the left. The distance from the mean up to this upper limit or the distance from the mean to the lower limit is 0.756. Right? So confidence intervals. And then hypothesis testing. So let's say that you're trying to show that the mean body temperature on day 1 at 8 a.m. is more than 98.6. Okay, so determine the parameter of interest. Well, again, the body temperature is on day 1, but the non-alternative hypothesis, so it says determine the sample mean, standard deviation, and sample size. You already did this. So you have that data. Determine the likelihood that the population mean is greater than 98.6 by completing a hypothesis test, one sample mean, in Statdisk. So we're going to go to analysis, and here's hypothesis testing, mean one sample. Because we're looking at one sample of data, right? It says use the significance level, so you got to change this to 1%. So that's our predetermined probability of a type 1 error, wrongfully rejecting the null hypothesis. So we set that up arbitrarily, 1%, 5%, sometimes 10%. Okay, again, that's the significance level. Now the claimed mean, that's the 98.6. Okay. The 98.6. We don't know what the population standard deviation is. Sample size, I think there was, again, I'm just making some of this up. I think it might have been 38. Sample mean, I'm going to put in, that's the sample again, the sample mean that we got. I'm going to make this up and say it was 99.5, okay? And then the sample standard deviation, again, I'm making this up. You have to go back and check your work from before, but I'm going to make the sample standard deviation 2.2, and I'll hit evaluate, okay? So we had one sample, we did a one sample means test. So in other words, we're comparing the mean, this claimed mean, this is our null hypothesis. Okay, this is the population mean, right? We kind of know that on average people, the body temperature is 98.6, so that's what we're comparing to. We want to see that our sample data is significantly different from 98.6. Well, our sample mean was 99.5, so is 99.5 significantly different than 98.6? Here's the sample mean, 99.5. We had one sample, we had a sample mean and a sample standard deviation. Then you come down to the t-test. The test statistic is computed from a formula, okay? It's a t-score formula, 2.52. That means that this 99.5 is 2.52 standard errors above the 98.6, okay? Now the plus or minus here for the critical value means that there was a two-tailed test run, mu not equal to, our null hypothesis is that it was equal to 98.6. Our alternative is that it's not equal to 98.6. So it's a two-tailed test. Our p-value is 0.016. And again, our confidence interval is given. But our hypothesis test, we compare our p-value to the significance level. And in this case, our p-value, which is small, it's still a little bit bigger than the significance level. So we fail to reject that the average body temperature is 98.6. Okay, so that's the kind of things that you got to talk about when you explain the results for the test. So again, what's the p-value? You know, you look and it's p-value 0.01. What does that represent? That's the probability of wrongfully rejecting the null hypothesis if you reject. Okay, if you reject. Okay, so a type 1 error is wrongfully rejecting. Okay, so that's what you're trying to avoid. You do have a small chance of a type 1 error, but you're not willing to take the risk because your allowable risk here of 1% is still actually less than this. So your probability of being wrong is like 1.6%. And you're not allowing yourself to take that risk. You're allowing yourself at most a 1% chance of being wrong by rejecting the hypothesis. Okay, so that's about it for the Statdisk online version and the week 4 project.